Good afternoon, ladies and gentlemen. Welcome to our webinar series iTAC Live on Stage. Today we want to talk about the way from MES to MOM and how microservice can help you to establish the smart factory. So we want to introduce briefly ourselves. Volker?
Thank you, Andreas. So my name is Volker Birch and I'm responsible at iTAC for R&D, research and development. So this includes development, testing, documentation, and as well solution delivery. And I'm with iTAC for 25 years so far.
Yeah, and my name is Andreas Rudel. I'm with iTAC now for 23 years, and I'm responsible for sales. Okay, let's have a look on the agenda, what we want to talk about in detail. So as mentioned before about the manufacturing operations management, so it's a relatively new term. I guess everybody of you is aware about the MES term, Manufacturing Execution System, and so we're going away from MES to MOM. And so that means we want to talk about a common platform for the new generation. We want to give some information how the market is recognizing us. So we will give some information how Gartner is rating us. And we will talk about our microservice approach with MOM. For sure, when we talk about microservice, then we have also to talk about functionality. That means about the modules in our solution portfolio, and for sure the product strategy and the platform service, which are included in our whole architecture. Though I guess then it's very relevant for you to know how you can run the system. So what are the deployment options, the different ones? And for sure, it's also relevant to talk about the security when you talk about a modern production management system, because right now the whole world is in collaboration, and you have to exchange the data between the production, the shop floor, the office, and the customers and suppliers. So it's very relevant. Backwards compatibility for sure, and investment protection is another part we want to address briefly. And at the end, we would like to summarize everything. And before we step in the first part, I just want to mention that we have a chat here, and so we can have a Q&A session afterwards. So please feel free to raise your questions within the chat. We will try to answer every question at the end of the session. Okay, though when we go to MOM, to Manufacturing Operations Management, we come from MES, and MES has been designed over years as a monolithic structure. So that means we had a single core interconnected unit, and that was scalable, but not that scalable as we expected today. So, and also from the maintenance point of view, it was a little bit more difficult to upgrade the whole thing. So that was quite challenging. Right now, we are moving into microservice, so we have more functional toolbox which could be extended by several servers and new modules like material logistics, transport control, and so on. And we can integrate here new tools very easy, like low code and business workflow engines. So we can achieve here a high level of standardization, and we can for sure also enhance the system with customer-specific expansions. So that could be also in the past, but we are right now much more flexible and better. And the integration of the whole MES MOM microservice into your digital strategy of your company is much more easy. The availability of the system is given for sure on-premise still, so though we're not dropping this option, and it's for sure also possible to run it on the cloud or in a hybrid mode. And last but not least, here when we talk about microservice, the scalability, that's also one major point we want to address here. So, Volker, when we go here now to our common platform, what can you say here?
Well, right. I mean, when we thought about starting this journey from MES to MOM, we had a vision in mind. And the vision was to address several challenges. One challenge was we wanted to have one system which is able to address multiple sectors in the industry. So we wanted to offer different functionality all combined on the same platform, being able to have something that consists of several building blocks that you can put together and deliver something which is exactly fitting what the customer needs. And this is actually what we did here. So we also certainly looked for a match in terms of technology, and microservice approach was exactly what was addressing and solving these challenges. So it was actually ideal for what we had in mind here, to redesign the system and to use the microservice approach. And while we did this, we also came up with a common platform. And this common platform provides the different common services which are needed to drive the different functional services of the system. So this actually represents the foundation of the system. And on top of this foundation, we can certainly also build other additional functionality, pieces of functionality, other building blocks in the future as well.
Yeah, okay. Let's have a look what analysts are saying here when we look to Gartner, and especially to the Gartner Magic Quadrant. Maybe you've heard about. So we are talking here about the ability to execute and the completeness of vision. So and as you can see here, we are ranked in the upper right corner. Though that means we have a very complete vision, and we are also able to execute this vision within the customer installations. And therefore, Gartner ranked us number first for complex discrete manufacturing, and second for batch manufacturing, and for sure also for highly regulated industries like medical device manufacturing. Yeah, if we go now to the microservice approach in detail, Volker, what can you tell us about the benefits here?
All right, well, there are certainly some benefits worth mentioning here. So starting with the integration. So we think that using microservices facilitates the integration subject quite a bit. And with integration, we mean integrating into other systems, also including the shop floor layer. We now have different potential here, so we can use different methodologies. We can use synchronous, asynchronous communication. We also have clearly defined, well-defined interfaces, contracts as well. So this all makes it much easier. Another very important topic to mention here is scalability and performance. They actually work together. So scalability means also scaling the system in a way that we are able to make sure that we can always meet the performance goals which are needed to run the system properly. We are certainly running the system in environment. Manufacturing environment is very demanding in terms of performance. So we need to make sure that we can always address potential bottlenecks which may occur. Also, when you as a customer decide to grow your factory, when you're going to add additional production lines, it's certainly going to increase the demand on the system, and that means you have to scale maybe in some areas. And the benefit of microservices is that you can actually scale exactly this area where you're finding the bottleneck in the system. So before with the monolith, you can also scale with the monolith, but it means horizontal scaling. You have to scale the whole system no matter where the bottleneck is in the system. Whereas with the microservices, you can actually just scale this one little piece where you find the bottleneck. And this also has a cost benefit because you no longer have to provide that many resources in order to scale in certain areas. Then speaking about development, there are certainly also some aspects worth mentioning here on the development side. So when we speak about making changes in a software, in an existing software application, it's more challenging to make a change in a larger application like a monolith, because it's quite difficult to make sure that if you make a change somewhere and at the same time make sure that there's no negative impact anywhere else in the system. Because everything is so much tied together, it's quite difficult to really judge and make sure that you're not touching something else and breaking something somewhere else in the system. With microservices, it's different. When you make a change, it's typically limited to one microservice. And microservice, I mean, the word is self-explanatory more or less. So when you make a change, it's limited to one service. And with the clearly defined interfaces between the services, you make sure that you're not breaking anything else. If you break anything else, it means you're breaking the contracts. And this is something that will easily be detected. Also, it's a benefit for the customer because it allows us to more easily and more quickly introduce changes in the system. So we can more easily and also more quickly introduce changes in the market. Another thing is deployment. So deployment is also more efficient. Here we're also looking at automating the whole deployment process. So there will not be any manual intervention when the system is deployed. Everything will be automated, which makes it more efficient and also more reliable when we go into the deployment scenario. And the last benefit that we see here, which is quite important, is certainly the system becomes more modular. I mentioned before, because we have these different building blocks, it's much more easier to compose the system exactly in the way that you as a customer want it to be.
Yeah, and modularity, I guess, is a trigger word getting us to the solution portfolio and to the architecture. So we want also to explain our solution portfolio. So starting with simulation. So there are always needs in a production to simulate the material flow, assembly process. You can have 3D models of the machine here. We are talking about virtual setting into operation and all the stuff around. So that's the first point or the first functionality which is needed in the production. And what else when we look into the architecture?
Well, there's certainly also the connectivity and the whole openness of the system. So we certainly want to integrate into the shop floor layer. We also want to integrate into ERP systems and other systems. And herefore, we are providing clearly defined interfaces, well-defined interfaces, which are also backwards compatible. So, which means that when you're investing into the integration into the MOM system, into the MOM software, you can be sure that we're not going to break it. So your investment is protected for quite some time. And we also offer the latest technology on the market, which includes everything that's needed in terms of IT security and so on.
Yeah, if we talk about then the functionality again, so we learned now that the connectivity and the architecture is very relevant for the digital factory. And functional wise, when we talk about traceability, or we say active traceability, or you can also say digital poka-yoke or interlocking. So we have always a bidirectional integration, for instance, to achieve a process interlocking between production steps, or to make sure that a setup of material is in accordance to the bill of material, that you get the right recipe parameters down in the process, that the material is not blocked or something like that, that the operator maybe has the right qualification. So we can do a lot of these checks nearly online in real time. And so we have really Industry 4.0 based production and can enable here really the digital factory. And we collect here a lot of data. And what can we do with this data?
Well, quite a bit more. So when we collect this data, for instance, from traceability, we can also use it for quality purposes. So here we can aggregate information, we can consolidate information, we can display it in a web-based front end, and the user can filter through the data. They can exactly find the information that they are looking for. We can also provide KPIs, and those KPIs can also be used in order to make sure that you're running your production according to your specification. So we can also build quality gates in production, which rely on the quality data. And if any of those criteria are not met anymore, you can raise an alarm, or you can actually also stop your production.
Yeah, and so quality data like measurements or failure data are related to the product, but we have much more data here if we talk about data which are related to a machine or to a certain production step. So we have here machine conditions, machine messages, logbook entries, and for sure with all this data we can calculate the typical KPIs like an OEE or utilization or you name it. And also a very beneficial tool. And going away from the machine condition, we're talking as well about material, right?
Yeah, that's more than just data. We certainly also have to make sure that physical material is available in the right place at the right time and in the correct amount. And herefore we have a module called Material and logistics. And we can also transport or drive AGVs, for instance, to make sure that material will be transported to the right location at the right time in the right quantity. So all this is taken care of by this module.
Yeah, and in these days we are facing also the requirement to have a documentation for the carbon footprint. So that means we want to document the energy consumption. We want to have a display on dashboards, what's going on in production regarding energy consumption. And so we can offer here an ISO 50001 conformance tool or conformant tool with our energy management module. What else?
Yeah, and then certainly there's another module which is about planning. When we have a lot of orders that have to be manufactured, we have to make sure that those orders can be manufactured according to the plan. So there's usually a due date behind an order. And in order to come up with a plan here, you certainly also need to know what is needed in order to run a work order. So you need to know exactly which resources, so which machines, which lines are available at the time when you are going to run these work orders. And also you need to take into account other constraints like material as well. So what this module does is takes all this data, all the information which is available, including plant maintenance, for instance, takes this into account and comes up with a plan which is cost optimized. So this represents the best optimized plan to run all your work orders through production. We can also take into account the actual situation from the shop floor. So when there is an unplanned downtime of a machine, something breaks down which was not planned, this information will also be immediately fed into the system, into the planning module, and it allows you to reschedule your plan.
Yeah, and when we talk about planning orders, planning maintenance, so we are talking as well then about the execution of equipment maintenance. So we can run here a certain task to replace material, to fix issues, to run the whole maintenance in the plant and collect this data, align this data with an ERP maintenance order or SAP maintenance order. And so we have here also a cost collection as well.
Right, and there's even more that we can do with the data. So from all these various modules, we are collecting this information. We can collect this information in a central location where it can be used for running reports, creating reports through business intelligence. And those reports can certainly be customized. So you as a customer, you can easily define your own reports. You can also use your own reporting engine here. And we're just providing the data basically. We can aggregate the information and then you can run your reports and filter through the information just as you need it.
Yeah, and last but not least, we're having our manufacturing analytics tool here with AI. So when you get high frequent data like noise data or vibration data, you want to predict what's going on in the future, but later on more. So now you get an overview, a high-level overview about our solution portfolio, where we see what is necessary to follow the digital factory approach. And going now to our product strategy. As mentioned at the beginning, we are coming from MES, so means manufacturing execution, going to MOM, manufacturing operation management, though the focus is now much broader. In the past, we did only focus with MES really on the manufacturing execution, that it means traceability, production control, production management, and now we are addressing also the side parcels like material transport, maintenance, APS, and all this stuff. So it's a much broader approach right now. So that's functional-wise, but we have also to talk about technology.
Correct, Andrea. So since we moved to the microservice architecture, there's certainly also a new technology involved here. So for instance, if you want to run a system which is composed of microservices, you need something to orchestrate these services. And herefore, what we use is Kubernetes. So Kubernetes is the third-party software which represents more or less the operating system for all the different containers. So the microservices are usually containerized applications, and Kubernetes makes sure that everything is orchestrated. It also make sure that we are able to scale. I mentioned that earlier. To make sure that we can scale exactly where we need to. Therefore, we also need to know exactly where we have to scale. So we have to have the information where we might have potential bottlenecks in the system. Therefore, we also have things like Elastic, where we can exactly monitor the system so we know what's happening inside the system as well. When we have a system which is composed of several services, there's also communication between the services going on. And a lot of this communication is asynchronous by nature. And in order to establish asynchronous communication, we need to have something which drives the communication, which makes sure that information and messages are delivered. And therefore, we use Kafka as our transport layer, more or less. And Kafka can also not only be used internally, we can also use it in order to integrate other software as well. I mentioned containers before, so Docker, this is certainly one of the buzzwords here when we talk about containerized software. When we came up with this concept, we certainly also standardized our internal development. So most of our services are actually developed in Java, and internally we decided to use the Spring framework. So all the Java-based applications, all the Java-based services are developed in Spring. And this is also to make sure that we can work as cost-effective as possible in development.
Yeah, coming back to our manufacturing analytics tool, so we are looking from the involvement from prevention to prediction, because everybody wants to have a look in the future, what will happen. So if we collect here vibration data and noise data, we can combine it with AI algorithm and can predict how long a tool will stay okay. Can you produce 10,000 parts more or 20,000? And so in the past you have changed the tool, let's say every 10,000 parts, and now you can use it based on the real information. Though it's a big plus, I guess.
Mm-hmm. Thank you, Andreas. And also speaking about these strategies, so we know by speaking with our customers that they are also looking at specific platforms. So they have a strategy in mind how to run their software in the future. There's not only MES here or MOM, there are certainly other software as well. And we know that a lot of customers are looking at, for instance, cloud-based installations, or they have their own private cloud, which might also include Kubernetes. So this is why we think that the system that we have designed fits exactly into our customers and into your digital strategy.
Mm-hmm. Okay, that brings us to our MOM services at all, and especially about the platform services.
Correct. So this is basically a very simplified architecture view of the system, of the MOM system. On the left-hand side, we see just a few of the potential functional services. And I mentioned we also have platform services. So the idea behind the platform service was to locate the common functionality, the common requirements of the multitude of functional services that we have. And we found out that there's a lot of overlap, things which are needed by multiple functional microservices. And instead of implementing these requirements into the services individually, so basically duplicating functionality, we decided to remove this and put this into a common layer, which we call platform services. So the platform service, they represent a set of technical services. They're also microservices, just like the functional services. And they provide services to our functional service. So basically, they represent the foundation. And any functional service or any other platform service in the future, they can make use of these services. And it also allows us, again, to be more efficient in development.
Yeah, let's have a look in the set of the platform services and let us explain in greater detail. First of all, we have a logging or monitoring service so that you can do easily the observation of the whole system. And therefore, we are using a third-party tool, so the Elastic Stack, and that provides the complete transparency here about logging and monitoring. So everything what is needed. What else?
Right. So, I mean, besides the technical observability, there's also a need to be able to be alerted whenever there's an anomaly happening in the functional services. So herefore we have the alerting and notification service. So in this service, you can define and configure your own alerts, your own anomaly detection. For instance, if a KPI goes beyond the set limits, you can make sure that someone will be informed. You can define the setting of the anomaly of the alarm yourself. You can also define how the information will be transported, whether it's going to be through email, text messages, whatever, you name it. All this can be done by the service.
Yeah, then we have our filtering API, so this is a centralized API service, and so it's used to harmonize the whole communication, because maybe some of you, some existing customers know the key value pair structure and API. It's something similar, because when you do a request by an API, you don't want to have all the data back, only some of them. So that means you can filter the data, and that helps us to harmonize the iTAC workbench, for instance. So that's the user front end. So you have a common style here, and you can really harmonize everything in the communication here.
Mm-hmm. Right, Andreas. And filtering is, for instance, something that typically a user does, perhaps in someone who's sitting in front of a web service, in front of a screen in his browser. And what they want is when they make adjustments to the screen, to the data that they see, they want to be able to store this configuration information somewhere in the system, and they want to make sure that the same configuration is going to be available next time when they log in. So herefore we have something what we call profile service. So the profile service makes sure to safely and securely store the information, the configuration information which is tied to a certain user in the system, and make sure that this information is available the next time the user logs in. So what is this information? This could be information about how to filter stuff, but it could also be information about how to display information, like what columns should be displayed on the screen, how sorting is done, and these kind of things. And it's quite important to separate this functionality and locate this in a centralized service, because we're speaking about personal information here to some extent. So we make sure that this information is just available for this one user who actually owns the data, and not to anyone else.
Yeah, what else do we have? We have a storage service here. Still in the modern architecture, like our MOM system, we need to have the capability to store files like Excel files, because we need them for a transfer service when you want to integrate data into the system. But we will also explain later with another platform service.
Mm-hmm. And then we also need to be able to run certain jobs in the system. And what is a job? A job is something typically which happens or needs to be triggered periodically. So it's something which needs to run maybe once per hour or once per day. And this could be something which aggregates information. So like for quality data or for reporting data, we want to make sure that we're capturing this data after a certain amount of time. Could also be used for anything else in the system where the user wants something to be run on a periodic basis. So here we also have a front-end application, a web-based front-end that the user can use in order to define and configure exactly when to run which job in the system.
Yeah, then we have our persistence layer. So it's a technical abstraction layer for managing the access to the different databases. And so we want to avoid to have proprietary access to databases. And though you want to be independent maybe from a database vendor, so you want to get rid of one vendor because its license model did change, and you are not in favor of this license model. So you can drop vendor A and replace it by vendor B. That's possible with our persistence layer here.
Mm-hmm. And now we get into the area of security. And again, this is also about who can access what information, who can use which functionality in the system. And all this functionality is also centralized in one single service. And we did this on purpose because we want to make sure that everything which relates to security is centralized. We want to make sure that this is not divided into several services, because this would probably make it more difficult to make sure that there are no security holes in the system. If everything is centralized, it's much easier to make sure that everything works properly. And what this service does is it makes sure that a user gets authenticated properly, which means we make sure that whoever is going to log into the system is actually the person they pretend to be, or they are. And also it makes sure that you can only do those and run those activities in the system that you're authorized for. So here you can exactly define what a user can do in the system, what functionality they can use, which data they can actually see, they can display. All this is centralized in this module. It also has the capability to integrate into existing systems at the customer, so we can synchronize with LDAP, we can synchronize with Active Directory systems. And also it makes sure of providing single sign-on and single log-out in the system. That means when a user logs into the system, this user is logged into the whole system. There's no other login into any other module. There's just one single point where the user provides their credentials. And the same is true when the user logs out. The user's logged out in the complete system, which means once a person is logged out, they can no longer use anything else in the system anymore.
Yeah, and when we then have a look to our data transfer service, so we have spoken about a storage service, and here we see the need for it. So if you want to process data, for instance, from an Excel file, then you need our data transfer service, and so it's very beneficial when you want to configure the system. So you can define in an Excel sheet the machine definitions, the equipments, the line, the ERP groups, some other master data. And those data could be easily uploaded from an Excel sheet, for example, with the data transfer service. So it's a very flexible tool, and it's needed for, or could be needed for a lot of functional service here. So, and what else?
Well, there's also one more very important topic here, and this is being able to know exactly what's happening in the system, not just on the technical layer, but also on the functional layer. So like there might be some sensitive areas in the system. For instance, we spoke about authorization. So whenever someone, maybe the admin, decides to change what a user is allowed to do, this activity is stored in the system. It's stored in the centralized service. And so we know exactly who did a change in the system and when they did it and what they did. So this is all logged in the audit service, and it's also available for as long as you need it, and it's available in a central location. So this monitors basically all the sensitive information in the system.
Yeah, then we have the data translation service. It helps to manage a different language, for instance, for master data. And when a user then logs into the system, going abroad in a different country, then he can log in with his own language, and his neighbor, which is a local maybe, has also his own language, which is quite difficult. And so a data translation service is also a must in a state-of-the-art MOM system, I guess.
Right, Andreas. And we spoke so far about collecting information. And since we're collecting a large amount of data in the system, we have to make sure that we can always ensure that the system works properly, that the fact that we're collecting a lot of data is not going to impact the performance of the system. So there is another service which is called data retention, and this provides the functionality to purge the production database after a set amount of time. So you as the user, you can define your own time. You can define how much data or how long data is going to be collected and made available in the production database, and after what time this data will be sent to an archive database for long-term storage. And the goal is here to keep the production database as lean as it's needed to make sure that the performance goals are met over time.
Yeah, and when we have a look then to the next service, so there's maybe the need to develop own or your customer specific back-end workflows. There we have included a BPMN engine, though we are using here Camunda, and that enables our customers or also us when we do the service for the customers to define here workflows, and we can combine it still with our scripting engine. But we will later talk also about the custom APIs. Yeah.
Right, Andrea. So this was addressing very much additional functionality on the low-code design in the back end. We have the same method also available for front-end applications. So for web applications running in the browser, we also make available a low-code engine here. And using this low-code approach, you can basically just use drag and drop in order to create your own application. And this application can also be integrated into our Workbench concept, just like any other plugin, which comes from iTAC. And everything can be running in the same browser. And also, it can participate in the single sign-on, which we mentioned earlier. So it can look the same, can have the same look and feel, just like any other plugin, even though it's developed and running on a different platform.
Yeah, and last but not least, we have a service which makes life easier for our system administrators, because when you have to manage the different license keys and different tools, it could be quite challenging. So we centralize everything in our licensing service, so that's ensured is that the whole system is always running and proper in that way. Okay, that was the overview to our platform service. Now we are going to our deployment options. What can you tell us about deployment options, Volker?
Yeah, Andrea. So there are actually 3 different deployment options which we offer, and we think that this exactly matches what our customers need. And number 1 is a cloud-based approach. So we know that a lot of customers are following up on the cloud. Also, we took into account the cloud from the beginning of the design of the MOM software. So even though it's not a cloud-native software, which actually we didn't want it to be, it's designed for the cloud, so it can easily run in the cloud, and you can run it in different ways. So you can just host it on the cloud. But if you like, you can also use dedicated services from like Azure or AWS. So we mentioned things like Kubernetes or Kafka before. And those services, they can also be made available by the dedicated service on AWS or Azure. And you can basically swap this out for the, let's say, cloud proprietary applications. It's not a need, it's an option. But just to be clear here, the system is not designed to rely on the native services from AWS or Azure. We're completely cloud agnostic here. The system can run on any cloud provider. Then the second option, this is what we call private or customer managed installation. So here it's basically a customer cloud, which could be just simply maybe a Kubernetes cluster running at a customer, where there's not just MOM or MES running, where there might be other applications deployed as well. Typically here we find, for instance, SUSE Rancher or the Red Hat OpenShift, the commercial Kubernetes applications in the market, and we can also run our system on these Kubernetes clusters. And the third option is basically the turnkey solution. So if you don't have any of that, so if you don't want this to run the system in the cloud and you don't have your own private cloud as well, we can certainly also offer what we call a hardware or software-based appliance. And the appliance basically provides everything that you need as a turnkey solution. This comes with everything that's needed. It includes all the third-party software like Kubernetes, Kafka, but certainly also our applications for MOM as well.
Yeah, and we are using internet technology here for our iTAC Workbench. So it's an HTML5-based front end. So I think we are living in a very risky world. So we have also to talk about security, how our system helps to have a safe life, so to say.
Right. So cybersecurity certainly becomes even more important. I think it becomes more important with every day. And there are certain drivers here. So one is certainly demand from the market or from customers, but there's also a demand from government agencies, like there's regulations in the market. So just recently, I guess a lot of you know that there's the Cyber Resilience Act of the European Union, which is going to be established pretty soon. It's already clear what the demand of this regulation is going to be. So when you're designing software, you have to make sure that you can meet all these goals. And in order to do this, you have to start early. So you have to already start with your processes. So the processes that you have established in order to develop software have to make sure that you can already comply with all these demands in the market. And so you have to establish your own guidelines on how to handle security during development. There need to be clearly documented processes in place, and everyone has to follow them. You also have to train people to make sure that they know what to look for. And you have to monitor your software. So you have to have systems and tools in place to check what is exactly contained in your software. So typically software today, especially Java-based software, there's not just software that you create in-house on your own. You're also pulling information, you're pulling third-party software in. And this could be commercial software, but it could also be open source software. And when you use open source software, you have to consider two things. First of all, certainly you have to make sure that you are compliant with the open source software licenses to make sure that they are compatible with commercial software. But number two is about security. You have to make sure that there are no vulnerabilities introduced to this third-party software. And herefore, there are also tools and software in the market, available in the market from third parties, which can exactly monitor what is contained in your own software. So what other components are part of your software that you're selling, and they know exactly what is inside. And through databases where vulnerabilities are kept track of, the system can exactly create a report for you which vulnerabilities are affecting your software. And this is exactly the information that you need in order to address potential issues here. So whenever there's something coming up, you need to have that information first. And once you have that information, you can certainly go in there and fix it. Then speaking about product architecture, we mentioned the platform services earlier. Yeah. We mentioned the unified IM. This is a dedicated and centralized service, and we decided to centralize this functionality in a single service to make sure that the chances of introducing potential flaws in the system is very much reduced. It's much lower when you make sure that this critical functionality is located in a single service. Then also, we think that microservices in general are a better fit of making sure that we can comply with the increasing demand on the cybersecurity side. So it's easier to fix things, something that comes up. You never know today what's coming tomorrow, because like I said, there's also third-party software in there which has to be monitored, and we don't know exactly what might be found tomorrow. So you have to make sure that you can also introduce changes very quickly. Then speaking about features again, this is also something that the Unified IM takes care of. We have features like single sign-on, so there's one centralized screen where the user logs in, where they provide their credentials. Also, we have the centralized logout. We have centralized administration screens to configure the authentication and authorization. So all these things are also considered here, and they are designed also as state-of-the-art. So every time we work on this area, we also make sure that we're not introducing anything which is proprietary. So we try to rely on what is pretty much the standard in the market. Because standards are pretty much, let's say, a safe bet, and if anything comes up, you know very early, you get very early alerted about a potential issue. Then once the software is completed and before we deploy it in the market, before we can sell it, And before we release it, there's another quality gate that we have to meet. And this is what we call penetration test. So this is a very specialized kind of test. It typically happens very much at the end of the process when everything is already tested from a functional point of view. And here what we do is we install the system or the software on a dedicated system, and we allow a third party to go in there and just act like a hacker. So trying to find any, let's say, holes in the system, anything which shouldn't be there, anything where a potential attacker might hack into the system and maybe get access to information they shouldn't be. So we're completely open here. We don't tell the penetration tester what to do. They decide on their own what they want to do. We also give them information about the system so they know their way around. And the goal is to make sure that once they are done, there are no critical problems detected. And speaking about process again, processes are fine, but we also have to make sure that they meet regulations and that they're also certified. And herefore, we have worked quite intensively to make sure that we can meet, for instance, the ISO 27001 certification and also the TISAX certification.
Yeah, okay, great. So then let's talk now about the backwards compatibility and let's say investment protection as well. So if we have a look now on the shop floor integration, we have here our concept. So that means we have on the top the iTAC MOM suite with an EMS API service adapter. So that means we have here a shared library. So that means our software is able to talk Java, C, C++, VB, .NET, you name it, and for sure also REST, what we see here on the lower right. And if we need some layer in between for the integration to certain machines, like when you have a PLC-driven machine, you want to use OPC, OPC-UA, for instance. If you have some injection molding machines, you have a different adapter like Euromap or something like that. And so we have here always the right library for the integration. And when I'm talking about investment protection and backwards compatibility, that means we have this API layer stable for more than 20 years. So that means a machine which has been integrated or years ago, it's still running with the current release. And that's also the strategy for our future. So that means existing customers which are using a version 9 or version 10 release right now will be able to move to MOM 11, still using this API stack here for the integration. And when we have a look on the MOM architecture with the shop floor integration at all, maybe you can give here.
Yes, maybe I would like to. Yeah. Thanks, Andreas. So maybe I would like to focus on the difference between, let's say, what we had so far and what's new in the MOM. So Andreas also already mentioned that there's certainly also going to be the backwards compatibility. So we see the same protocols here between the shop floor building blocks, the components and libraries, and the backend. So this will still be available to make sure that we can speak with existing software on the shop floor layer. The interesting difference is that we have now got rid of the traditional load balancing and failover feature, which used to be on the client side. Now it's it moved one level up onto the server, and it's now provided by what we call load balancer. And load balancer is not something from us. It's actually something that you can buy in the market. And I believe that you as a customer, you probably already have it somewhere running on your IT for other purposes as well. And it's something that is needed basically every time when you run a web-based application. So for instance, anything which runs in the browser, any application that runs in the browser, it doesn't come with failover out of the box. Failover in these cases is typically provided by an application called a load balancer. And this is a centralized application that provides this functionality. In order to reduce the complexity of the system and of this feature, we decided to get rid of the client-based failover. It didn't make a lot of sense anymore to continue using it. So instead, we decided to have just one common layer for any communication path, any communication channel, using this typical standard state-of-the-art load balancer that you can buy from anywhere, any provider in the market.
Yeah, and from here going now to our template approach, because we have learned we have a very broad API stack. And right now we have more than 500 standard APIs which can be used for different use cases. For instance, if you want to activate a work order, you want to upload data, test result data to a serial number, to a batch, you want to get down configuration data like recipe data, you want to check the skill of a worker or whatever. So that means there are more than 500 of these standard functions available. And if you go then now to the machine integration or to an integration in a special client and user front end, then you have a lot of traffic here to manage. And that's the thing we want to avoid, to be efficient and to be flexible still. And so we developed or invented years ago our custom function approach. So custom function means it's alignment or definition, also kind of workflow of certain API functions. And so you can really make the integration to your machines much more easy, because the complexity is no more available to the machine programmer, or he has not to know the complexity. He's just caring about the in and out. So that means this custom function is running on the application server, and the machine vendor is just dealing with the in and out parameter. And when we assume we have a certain amount of these custom functions, let's say 10 to 25, it depends how many modules you're running, what kind of functionality you're using. So on your production process, it depends basically on your production process and your needs. And so we can define here really templates using the single origin APIs or the combination of custom function here. And so we have here finished function blocks. These function blocks are encapsulated, so the complexity is gone, so to say. And it enables easy cross-plant changeovers, because you can store this custom function on the application server with their own revision. You can export this, import to another instance from a test production environment, and so on. So it helps you to do a proper machine integration. And as mentioned before, it's still investment protection, and it's needed to do production control, because what we have learned before, we have always with an API, that's still the behavior of an API in general, we have a bidirectional integration. And that's the most important thing, to do a standard or a standardization of the whole plant integration. So now we have spoken about the shop floor, so that means the user front end and the machine communication with the different layers. But we have also to talk about the integration of the master system, like the ERP system, Volker, right?
Right, Andreas. And so also here we had the clear goal in mind to make sure that we can offer the same functionality, the same capabilities here on the ERP level as well. And I think a lot of you know already how it works in the current version of the system. So the picture here is quite similar, and we're offering very similar capabilities. We have certainly also introduced new things like supporting the OData. There's still the ability to use the transfer tables to communicate with ERP systems such as SAP, where we also have the existing SAP service adapter. But you can also use the transfer tables to communicate with other ERPs as well, using Orchestra or maybe your own integration. And what we're certainly going to do is this part of the application will no longer run on the existing technology. It will be migrated onto the microservice platform. So there will be some differences visible here and there, but the goal is really to make sure that we can still communicate in the same way, and there will not be a big transition here happening going from MES to MOM.
Yeah, maybe one more comment here. So we are very flexible here because we're doing always a field mapping. So it doesn't matter how you have arranged data in your ERP system, your SAP system, or any other ERP system, because doing the field mapping, we have not to follow a very strict structure. Though we are flexible here, and so you can use your data as they are, and that helps you to define your process in that direction as well. Yeah, now coming to the end. So when we summarize everything what we have spoken about, so we can say we have a scaling and upgrade capability here for all the individual service, which is a big plus because we can do it individual for each service. What else?
Yes, and individual services also means that every service is the owner of some data. And this data is also located in their own data model. And we don't want other services to access information from another service, because this is just create additional dependencies, additional issues in the system which we don't want to have anymore. Is this separation of data and services, this makes it much more easier to make sure that the system works properly. And speaking about security, Andreas?
Yeah, as we have learned, so we have security by design, security by default. That means we're starting on the highest level and each customer can go down.
Right, and certainly backwards compatible API. We mentioned that before. We make sure that we can still speak with existing software integrations.
Yeah, then we have for sure a state-of-the-art design, and as we have learned, we have various deployment options if you want to run it on premise, hybrid mode, cloud mode. We have then the low-code development level here, which is possible.
To be more efficient, certainly, and speaking about efficiency, there's also performance. So we mentioned monitoring, make sure that we know exactly what's happening in the system, and then shop floor data collection. We saw this also in a slide, how this works in the future system or in the MOM system 11.0.
Yeah. And now, as I mentioned at the beginning, we have opened a Q&A session in the chat. Let's see if some questions arrived here. Though, then we would like to answer here. So let's see. So there's one question here. Is a microservice approach the future?
So when we took on this journey, going from MES to MOM, we looked at what we wanted to have, the capabilities and requirements. And it was pretty clear very early already that the microservice approach is exactly what we need, is exactly what is going to meet our expectations. And that's why we decided to use microservice approach. So for us, it's just a perfect match for what we're doing.
Okay. So there's another question. Since what version of MOM there's support of single sign-on? It is applicable only for Workbench or for the whole system?
Well, I mean, it's certainly going to be available in the Workbench, but also there are interfaces available on the centralized service Unified M, which can be used for other applications as well.
Okay. Yeah, and then another question, where the API load balancer will be running. If you consider that backend will work in a cloud, I would assume that the API stack should still run as close as possible to the shop floor.
Well, right. I mean, if the backend system's running in the cloud, you certainly have to consider latency. So you have to make sure that latency is not introducing any additional amount of delay in the communication, which might affect your production. So it doesn't really matter where your load balancer runs. If you have delay because of latencies, because of, huge distance between your shop floor and your cloud, you have to consider that.
Okay, and the last question which arrived here in the chat is, what about the custom-made clients? What made in Java? What about these clients in the future?
I guess this question probably refers to Java-based rich clients. So you have to consider that there might be a time when Java decides to basically retire a certain piece of technology. So that's something to keep in mind. And whenever something is going to be retired, you have to look for an alternative. So we clearly see that the web-based front ends are actually the replacement for Java-based clients. This is why we decided to drop our workplace application, and that's why we focus on the workbench now. So it's really something to keep an eye on if you're running a Java-based custom application today.
Yeah, so now we are almost on the end of our webinar today. We just want to mention that you can find additional links in the chat, and that our next webinar will start on March 20 when we talk about manufacturing analytics in detail. So then we can say only thank you for your time, thank you for your interest, and yeah, see you next time, and have a nice day.
Thank you very much.
Bye.